So I would like to discuss the differences between imperative and functional way of programming in Python. To do that, so we need a problem that is simple enough so that it can fit in this screencast, and yet complicated enough so that we can show a few subtle things. So for that, I chose a problem that was inspired by my Vim usage. If you're a Vim user, probably you hate pressing escape because it's all the way in top left of your keyboard, and especially if you have a MacBook doesn't have an escape key anymore. It has this touch bar, which I don't know how to use. Um, and basically you hate it. So there are suggestions that people do. One of the suggestions is that in insert mode you can map a two key combination to be escape in a normal mode. One of the things that is very popular is JJ, and then so they say it's not common enough. Not so many words have JJ in it, so you're fine by mapping it. So I was curious to see, and I checked this list of words that come out of the box with the MacBook in OS X to see if there are words with JJ. So I see there are two of them. I don't know how to pronounce them. I don't think I will ever need to type them. And some people also do JK, for example. JK is slightly better as only one word. But anyway, that inspired me to write a Python script to see, okay, what are the key combinations, two-letter combinations that did not appear in any word in the dictionary. So let's write a Python code. I did write one before, so let's try to do it together again. So first thing first, let's open the dictionary. User share dict words, I believe. We want to read it. Word file and words become. Let's split it here also. Let's print to see everything is wired. Let's print the first 50. Okay, nice. But I see there are two issues, that some of them have this capital in them, and then some of them have only one letter. So let's filter those and make everything to be lowercase. Run it again. Okay. The character did not appear anymore, and then everything is lowercase. So you're good with that? Okay. So for every word in the words list, I want to do two things. First, I want to find everything that all the two-letter combinations that appeared in the dictionary, and then in order to find out the ones that did not appear, I create all of them and then make a subtraction. But for every word, we need the two-letter combination for every word. So let's say words two combos. What do we need is, let's say, we need an index that goes from the beginning of the word till the end. Well, probably minus to the end, and then it chunks two characters next to each other. And then we need to have dict two combos, dict two combos union of, let's say, words two combos. Yeah. There's a set. Okay. Let's print this to see if everything worked. it should give us all the combinations, two-letter combinations that did appear in the dictionary. So what we need is all two combos. Let's make a set. We can actually do it with the F string. We need all the lower case characters. I believe it is ASCII lowercase for p in string dot lower. Yeah, and then our result becomes all two difference with dict2. Okay. Let's print the result to see what are the lists. Oh. Nice. How many are they? Well, 59. Okay, so I got my answer. There are 59 of those. And the way I wrote this program is really imperative. So for everything I needed, I made a for loop or even two for loops. Now let's make it a bit more functional. Let's call it functional. Let's load the other one. So, okay. If you look, there are a bunch of for loops here. The first one is a map and filter. That's probably everyone is used to, so I want to leave that alone for now. I'll discuss it later. This one is a bit tricky. And then there is accumulator kind of loop that goes over the list and accumulates stuff. And then there is a product that we explain later. So it creates all the key combinations of characters. Okay, so let's start with this tricky one. Well, it's not that tricky, but you have to have seen it before. Okay, let's bring up a Python interpreter. And the pattern I want to use is called zip. I don't know if you've seen zip before, but it's a very tiny, useful built-in method in Python, and actually it does exist in all programming languages. So if I zip apple and orange, Python 3 gives me a generator. But what does this generator give me? If I consume it completely, it gives me a list of tuples that matches the first character being A of the first one with the first character of the second one, and the second one to the second one, third one to the third one, and so on. You might ask, how does this help me? Because I only have one word here. So let's see, my word is apple. So if I do the zip of words and then word shifted by 1, hopefully this gives me what I needed: AP, PP, PL, and LE, which is what I wanted. Okay, so let's replace this by set of zip of word and word shifted by 1. As a difference of between this program and the one before it was like a string of 2 characters. Now we replaced them by list. In order for this to work, we need to do the same here. If I run this, hopefully I should get again 59. Yes. Cool. Okay. Go to the second for loop. This one is a typical pattern of accumulation. So you go over a list and you accumulate something. You do some operation over the elements of the list and then you accumulate it. Okay. In most functional languages, there are constructs for this. The most notable one is called fold. And in languages like Haskell, there are fold left and fold right. In Python, it's called reduce, and it resides in funcutils, in functools. Functools has reduce that the first argument is a function that has two arguments of its own. The first one is the accumulator. The second one is just the element, which in our case is the word. So we need to do the accumulator union. Okay, and the second one is just a list of words that we want to go over. And the third one is the initial value of the accumulator. If I run this, okay, we still get 59. That means that we are good to go. Okay, so we replaced 2 for loops, and then we have 2 more to go, and this one, both of them are in this one line. What it does is basically very similar to what we do in a database when we merge 2 tables. It's something called a Cartesian product that gets all the combinations of the first set with the combinations of the elements of the second set. And it's also called product in Python, but it does exist in itertools. Product of string dot lowercase yes. If you run this, okay, we get an error because itertools generates a generator. If I put it in a set constructor, it does work again. Okay, sounds good. Okay, so far I'm happy with this program, but okay, we went from this to this. This one you can argue that doesn't have really multiple imports, doesn't really use a lot of functions from different modules, whereas this one does use reduce and product for functools and itertools. That's caused me to import these 2 modules. But if you look at this one, there are for loops, 4 or 5 different for loops in this, and they are meant to do different things that are conceptually different. This one is really a map and filter, and this one that goes over the list and accumulate it is just an accumulator or a reduce kind of thing. This one is really a zip kind of construct. And the last one is really a product. If you look far enough to this program, they are all for loops. They're all the same, and it really like triggers the same part of my brain. Whereas in the other one, as soon as I look at the, for example, reduce, I know, okay, so the initial value is a set. Basically it's gonna generate a set, and it goes over the list of words, and it tells me that. So it really conceptually it signifies that, okay, now we are going to reduce something. And also the same for the other one, for the product. It does tell me that, okay, I'm going to do the product of 2 different sets. And if the 2 sets are the same, I believe there is even a special parameter that just repeats it. So I just don't. Okay, it just work. So I just don't need to repeat it 2 times. Okay, so that's the difference between these 2 sides. And the only for loop we did not replace, it's because Python designer decided that for doing map and filter, this is the normal syntax to use. Although you can do that. So let's define a simple list, AA. Not very creative, but okay. So if I do the map which is also a built-in function on lambda that takes a lambda and then applies that lambda on a list. And like the zip, this gives me a generator. And if I really want to see what it does, I have to consume the generator. As you can see, everything is small. I can also replace this my list with the filter that also gets a lambda. This lambda should generate a boolean. If I run this, okay, now it does work as the equivalent one here, but you can argue that this syntax is a lot more ugly. It's a lot uglier than the other one. It has its own usages still. For example, if you want to be lazy programming, if you don't need all the list to be lowered and filtered, then you can use this. Otherwise, the better syntax is to use this syntax. But basically, whenever you see a list comprehension, it should triggers in your mind that, okay, this is a map and filter. Okay, so that was all I had for you guys, and see you next time.